Hi again. Today the topic is random variable. This is much more important topic and this topic contains more subtopics. You will see all these things in this video. First, the random variable. Actually, we have seen random experiment, right? Random experiment means what? The outcome should not be predicted, but it is one of those several possibilities. This is random experiment. The same applies here. A variable whose value cannot be predicted. So random variable is a variable, means it's a value which cannot be predicted, but it is one among the several possibilities. It is one of those several possibilities. Same like random experiment. Okay, for example, number of heads turns up when when tossing a coin 3 times. I'm just tossing a coins 3 times and they are asking the possibilities for heads up. Okay, so I can easily say the random variable will be 0 1 2 3. Okay, so 3 coins, so up to 3. One dimensional random variable. Assigning a real value. Okay, we are assigning a real value to each outcome of an experiment. So there are so many outcomes from many experiments, right? So one experiment, we have to consider the first experiment, like any one experiments that has many outcomes. So each and every outcomes we are assigning a value, real value. This is called one dimensional random variable. Okay, so we need to assign a real value to all the outcomes of one experiment. So the corresponding data which is known as univariable data. So we have got one data, right? That is univariable data. Okay. Next, two-dimensional random variable. Connecting two outcomes at a time to a real value. So here we are assigning a real value to all the outcomes. But here we need to connect two outcomes to the real value, provided that those outcomes are drawn from same sample space. It should be in the same S. So we need to connect two outcomes in the same S to the real value. So that is two-dimensional. Next one, the corresponding data. So we have seen here the corresponding data is what? Univariable data. Same here, it is bivariable data because we are considering two outcomes. Okay. Discrete random variable. Discrete means countable. Okay, so discrete random variables. If random variable x takes a finite means it is countable, or finite number, or countably infinite number of values. So it is countable but it is infinite number of values. Okay, so the x is said to be discrete or a random variable. Actually here x is nothing but it has the numbers which is countable. So or else we can say it is countable but infinite numbers. For example, it is not countable, like it will be counted but it is up to 100 means this is infinite number, but countably infinite number. Okay, so x is said to be discrete random variable. It is a countable random variable. So x which is equal to x1, x2 up to xn. Let p of x equal to xi, small xi, which is equal to p of I. We can easily say this term p of capital X which is equal to small xi. I is nothing but the numbers 1, 2, 3, 4 up to n, right? Which is equal to pi. This is said to be a probability function. Okay, only if it satisfies some condition, because this random variable has some conditions, like it should be greater than 0. Normally possibility has higher limit is 0 and lower limit is lower limit is 0 and higher limit is 1. So it should be less than 1, probability should be less than 1 and greater than 0. That's what here they are saying. Greater than or equal to 0, and it should, the largest, like the upper limit will be 1. Summation of p should be 1. That's it. So because it is a probability function. So collection of pairs xi, pi, where I which is equal to 1, 2, 3 up to n. So we are going to put a collection of pair, like x is in a row and p is in a row. You can see here x is in a row, x1, x2, x3, likewise p is in a row, p1, p2, p3. So this is called a discrete probability or the probability distribution or the probability mass function. So it is countable. It is a probability distribution, discrete or mass function. Okay. Next comes the cumulative distribution function. Cumulative means addition. Will always use this denote. Okay. So this is nothing but summation. Cumulative means sum or add. So the function f of x, which is equal to p of x less than or equal to x means small x, means we can easily say this thing as capital X, summation of xi, which is less than or equal to x, p of xi. Okay, it's just a general equation, but in problems it is very easy actually. P of xi, where they are taking this term, p of xi will be equal to p of x, which is x equal to xi, where we can easily say this thing as the second term f of xi minus f of xi minus 1. Okay. Next comes the properties, like f of x is what? 0 to 1, because it is a probability. Probability only has 0 to 1 values. If x1 is less than x2 means we can easily say in function also f of xi, which is less than, like x1 will be less than x2. Same appears here. If x has the limit a to b means the probability of this whole thing will be function of b minus function of a, like upper limit minus lower limit. Okay. And next comes the expectation. Expectation means E. Okay. The expectation of discrete random variable x is defined as, so expectation of x, okay, expectation of x will be normally the summation, whole summation, but here we are adding a term here, x into p of x. Okay, just remove these i's because I is nothing but 0 to n. For example, if I say x p, x1 is 1, x2 is 2, x3 is 3, and here 0, 0, 4, then 8. Likewise means we can easily say x1, x2, x3. That's the thing here, I. So just remove that. 1 into 0, 2 into 4 plus 3 into 8. This is the meaning here. X into p of x, x into p of x plus x into p of x. So the whole summation will be the answer for expectation. Next thing is mean. These are very important actually. Mean is nothing but the same expectation of x. Okay, so summation x into pi. But here variance is nothing but, we can just remove these things. We can easily directly say like e of x square. So we need to replace this x by x square minus e of x the whole square. So this is a formula for variance. Okay, so it's like summation of x square, because here only x into p of x. I am just replacing the x by x square. So summation of x square into p minus mu x square. Mu means mean, so mean square, the same formula. Okay, so let's see a problem here. A random variable has following probability distribution. So they have given one distribution. First of all, we need to find the constant here. What is the constant? C. For that purpose, we need to equate this equation to 1. Then only we can find C here. So they are asking first find C. Then they have given some limit. The x should be less than 3, 0 to 4 likewise. And then they want us to find mean and variance and also the distribution function. Okay, first of all, the p of summation p of x, this is the general term which is equal to 1. So just add all these p here and you will get a value for C. Okay, what are the things here? C plus 2C plus 2C, which is 5C plus 6C square. Okay, so from this thing we have got C which is equal to minus 1 and 1 by 6. Here negative is not possible, so only we have to take positive 1. Next they have given two limits here. X is less than 3 means x should not be equal to 3 but it is less than 3, like 0, 1, 2. 3 possibilities are there. Just add the C's here and you will write the answer. And again 0 to 4, just take 1, 2, 3 and add it and you will get the answer. Okay, and then third one, we need to find the probability function, right? So what is the probability function? Which is nothing but we need to substitute the C value here and you will get the 2 rows. This is the probability function. Next one, fourth one, they have asked mean and variance. In problem it is very easy actually. Just x into p1, like you can see here 0 into 1 by 6. So just omit this. 1 into 1 by 3 plus 2 into 1 by 3 plus 3 into 1 by 6. So 36. Likewise you need to add all these things, you will get the mean value. And then x square means you need to square this value, x square into p of x, like f of x. So here 4, 2 square is what? 4 into 1 by 3. Likewise I have written here 1 into 1 by 3, 4, 3 square, 4 square. Then minus of e of x is what? 59 by 36. So 59 by 36 the whole square, because it is nothing but mu x the whole square, which is mean square. Okay, so we will get the answer right, this thing. Next comes the continuous random variable. Before that we have seen discrete, but here it is continuous, so it can't be counted actually, and it is continuous. So a random variable x is said to be continuous random variable if it takes all the possible given values inside the limits. Let us say 0 to 4 means, which is less than x, which is less than 0 to 4 means the random variable should take all the values here inside the limit. That is continuous. It continuously taken the all values. Okay, next one is probability density function. Okay, probability density function. Consider a small interval. I'm just considering a small interval like x minus dx by 2. Dx means it is small, which is used in the integral, means integration is for small areas. So dx by 2 and again x plus dx by 2. Okay, these are the two limits, like two end. Okay, we can easily say this one is x minus dx by 2 and this one is x plus dx by 2. Okay, these are the two limits. So small limits, they have taken the small limit of length dx. So they have said this length as dx. Okay, let's f of x be continuous function, so that f of x into dx represents the probability that x falls inside the interval. So it is said to be continuous means, which is nothing but it that integral should take all the values inside this dx. Okay, so we can easily say like upper limit and this is lower end, so lower to upper. Okay, which is equal to f of x into dx. So here they have given in the graph actually. So x to dx by 2, this is one limit and this one is another limit. I am just taking the x point here inside, which is inside the curve, which is inside the limit. The function f of x dx represents area under the curve f of x. The function f of x is said to be probability density function. So this function, which is nothing but the density function. Okay, yes. And properties, they have the some properties like it should be greater than 0, we know that, and the whole integration should be equal to 1, then only we can find easily the unknowns here. Okay, next one, p should be like they have given the x limits as a to b, so p of a to b, which is nothing but in integral, because these are all things we have taken for the small regions. Small regions means we have to consider the integral. So p of x equal to a, so they have said x is a. You can see here, if x equal to a means x should have only a value like a. If it is so, you can easily say upper limit minus lower limit will be 0, right? So p of x equal to a means it is 0 in terms of integral, like in probability density function. Then they have given two limits here. Okay, so this limit can be written like this is not equal to, here not equal to, or else here not equal to, or else both are not equal to. We can written like this. So here what is mean? Mean is nothing but x into f of x, that's it. Where in before cases we have seen x into p of x, right? So the same appears here, integral x into f of x into dx, which is nothing but the mean. What is variable? Variance means which is nothing but x square. Okay, see here, which is nothing but, actually the term will be like x square into f of x. Okay, but here they have said like we can easily write like x square f of x minus of mu x the whole square. This is nothing but we need to replace the x by x square and we need to minus the term by square of mean. Okay, this is called variance. And next is cumulative density function, which is a cumulative which is nothing but the addition, right? So they have given f of x which has the limit minus infinity to x up to x only. Okay, so density function which is nothing but, this is important, up to x only. So we can easily write minus infinity to x into d of x will be equal to dx, like f of x into dx. This is a formula. For the interval a to b, they have given the interval as a to b. So mean will be a to b x into f of dx, x into f of x. If it is x square into f of x minus mu x square means it is nothing but variance. Okay, and there comes a property which is 0 to 1 and should be greater than 0 1. Actually f of x is called non-decreasing function. F of x is a non-decreasing function. If x1 is less than x2 means we can write it in as in the function. Next one, f of infinity which is equal to 1, f of minus infinity which is equal to 1. You know this is lower limit and this is upper limit. Likewise the upper limit should be 1 and the lower limit should be 0. F of x may have countable number of discontinuous. So they may have countable number of discontinuous. F of x which is equal to f dash of x of all the points where f x is differentiable. So f of x should be differentiable. So let's see a problem here. If the density function of the continuous random variable x is given by f of x which is equal to 0 and x which is greater than 0. This is the thing here. So they have given 1, 2, 3, 4 functions. First function is 0 actually, second one ax, and third one they have given, fourth one is also 0. So we need to consider only two things. They have asked what is a and then count cumulative density function here, and then we need to find the value. First I need to find the a value, so for that purpose I am just equating it to 0 1. Only two things are here, so by doing the integration you will get the answer as 1. So we can easily say a which is equal to a 1 by 4. So a which is equal to 1 by 4. Then cumulative density function, which is second part, like x should be less than 0, which is equal to f of x equal to 0. If it is s is less than 0 means there is no else, right? So it is 0. If they have seen 0 to 2 means we can easily say like 0 to x, okay, because we are taking only x here, minus infinity to x likewise. So 0 to x 1 by 4 into x into dx. Okay, this is a formula. So like this is a formula, like they have given the function as x, right? So they have given the function ax. So we can easily substitute the value here and you will find the f of x values. After that they have given one limit, x is greater than 2.5. So for this purpose, which is nothing but this is the lower limit. So I am just substituting 2.5 to 4. By doing the calculation, you will get the answer as 1 by 8. Next one, if the probability density function of a questions of a continuous random variable is given by, they have given one function here and they want us to find the mean and variance. Actually mean is x into e of x. Here x into e of x, there has a formula like u v1 minus u dash v2 plus likewise it will go on. So first find u and u dash. Here u is what? E power minus x. E power minus x is y actually, and u is nothing but x, because we are saying x into f of x, right? So this one is for u and this one is for v. So as you know, just find out all the values and substitute here. You will just substitute two terms alone and you will get a clear answer of 1. Then variance. Variance, which is nothing but x square into f of x into dx minus mu x square. So easily you can write, I just replaced it and then take the values individually for u and v and then substitute in the equation. You will get the answer as 2. So get the answer as integration value. But here integration minus mu square, right? So mu square means minus 1, which is equal to 1 is the answer. Then there have some properties for expectation. If x is a random variable and a is a constant, then e of ax we can easily write it as like a should be come out. So a into e of x. If x and y are random variables, then we can easily write like e of x plus y will be equal to plus minus into likewise. Okay, then e of x y will be independent, means we can easily write like this multiplication which is independent, and if y which is equal to ax plus b, so they have given an equation y which is equal to ax plus b, where a b are constants, means we can write this term as, I am just writing it as in the expectation, e of y which is equal to a into e of x plus b, that's it. Okay, and the fifth thing, constant of expectation will be a constant only like in differentiation. Then the properties of variance. If x is said to be variance random variables and a is constant, here v of ax will be equal to a square v of x, where you can see here the a is in square. But in case of e of ax means only a into e of x, we just need to take the a alone outside, but here a square will come because it is a variance. Okay, then v of minus y we can write like minus 1 into y, right? So I am just taking this 1 as the power of square, so we will get only the positive thing v of y. So this is like an even function, so f of minus x we will get the f of x only in the variance like sigma x square. And the second property, if x and y are independent, random variable. Then v of x plus or minus y means, like you can see here, which is in variable means if it is plus or minus we only get the positive one, whatever may be the thing. So v of a minus b will be equal to v of a plus v of b. Okay, so this is the thing. If a, b are constant and x, y are independent variables, it is a independent variables means we can easily write like v of ax plus by means we can easily take the a and b as square, and then 1 by a, here x by a means which is nothing but 1 by a, so I'm just taking out 1 by a as 1 by a square, v of x minus 1 by b square v of y, that's it. And the last one, if y which is equal to ax plus b, so we can easily write this thing as in the variable, like variable of y which is equal to variable of the whole thing. So here if I take a means it will be a square, but v of a constant means it should be 0, but x of constant will be, expectation in constant will be constant. Okay, so this is somewhat important thing actually. And if x, y are two random variables which is a dependent variables means we have to use like a formula, a plus b will be equal to a plus b plus 2 times of covariance of x, y. That's the thing, a square plus b square plus 2ab. Likewise here variance of x, y, x plus y will be equal to variance of x plus variance of y plus 2 times of covariance of x, y. What is the thing for covariance? Covariance of x, y means the combination minus the individual. So e of x, y minus e of x, e of y, that's the thing here. And here e of covariance for x, x means it should be the variance formula, like e of x square minus e of x the whole square. And if they have given for the two intervals a, b means we will write like e of a b minus e of a into e of b, where this thing which is nothing but we can easily write like this ab minus ab, so it should be 0. Okay, and there comes a note for a dice. So mean and variance for the number of dice is, if it is for expectation means we have to write like 7n by 2. If it is for variance we have to write 35n by 12. Okay, here 12, here 2, where n is number of dice rolled. So they have given a formula like 3 dice are thrown and we need to find the mean and variance. Just substitute this 3 here and you will get the answer. Like what is the formula for expectation? 7n by 2, right? So 7 into 3 by 2, which is nothing but 21 by 2. So this is the answer for expectation. And next one, variance of x, which is nothing but 35n by 12, right? So I'm just writing 35 into 3 by 12. So we can easily say like 35 by 4. This is the answer. Okay, and the next sum, 2 unbased dice. So they have given 2 dice or thrown. Find the expectation for sum 7. So through dice or thrown, and they have asked the sum 7. So in the 2 dice we can easily say like 1 6 and then -1 here. So +1 -1. So +1 -1, like it will go on and it will end in the 6 comma 1. So 1 2 3 4 5 6 possibilities are there, and we know the ways 6 power n, right? So 2 dice means 6 square will be equal to 36. So p of 7 will be equal to 6 by 36. So this is finished. And then expectation of x, which is nothing but expectation of sum 7. Sum 7 means we need to assume only the 7. So a 7, I'm just taking the 7 as outside, 7 into p of 7. So we will get the answer soonly. And then next question, if x is continuous random variable and f of x should be equal to k into x square into e power minus x. Okay, this is the function and they want us to find k and then the variance and then mean and variance. Okay, so for that purpose, if you need to find the constant means, you have to equate the equation to one general equation. So here x square into e power minus x, so formula will be gamma n. So this is, we have seen this thing in the gamma function actually. So n is nothing but here x power n minus 1. So n minus 1 is what? X square. So square. N will be equal to 3. So gamma n will be equal to 3. So gamma 3, which is nothing but 2 factorial. So we have got the answer as half. And we have to find the mean, which is nothing but n into f of x, and you will get the answer like half into gamma 4. By simplifying it, you will get the answer 3. The same applies here. Variance means x square into f of x minus x mu x, like this is nothing but the mean square. So by doing all the things, you will get the answer as 3. Okay, next comes the second dimensional random variable. Here joint probability functions or Morse function is of f of x y. So x y be the last 2D random variable. Then we can easily say like x equal to xi, y equal to yi will be equal to, I am just writing it in the and function. Okay. So P of ij means P of x equal to xi. This is the P of ij meaning, is called joint probability function. So it is said to be the joint probability function, means we can write like which is always greater than 0 and the summation should be 1, but here the summation not 2 because it is by, right? So I and j. The marginal probability function. Here marginal probability function of x will be equal to P of x minus x equal to xi, which is equal to j, which is equal to 1 to n P of xi plus xyj. Okay, the marginal problem function of y. So this is for x. So it is for y means, which is nothing but we need to differentiate it, right? So y equal to yi, which is equal to P of xi yj. So you can see here P of xi and yj. So these are the two functions for function of x and function of y. Next one, conditional probability function. Normally the condition will be like a by b, right, in fraction. So conditional probability function of x, which is given by, they have given in division. So x equal to xi by y equal to yj. So just substitute all these values in the normal values, like P of x equal to xi and y equal to yi. So from this here we have found this formula. And then the next one, P of ij by P of y equal to yi. So conditional probability function of y. So you can see here this one, which is nothing but P of ij by P of y equal to yi. This is a general form actually. So the conditional probability function of y is given by x equal to xi. So by doing so, we will get the answer with in terms of xi. So we can easily write like P of ij by P of x equal to xi will be the answer. Two random variables is said to be independent. So we can easily write this thing, probability of x y will be probability of x into probability of y. So this is the thing here, which is in terms of discrete variable. Okay, so cumulative distribution function. So cumulative distribution function f of x y will be given by the formula here. X should be less than x and y should be less than y. So we can write like this one, I into j into, right? And then there comes some properties actually. Properties will be equal to f of minus infinity y will be equal to 0. Likewise x into minus infinity will be equal to 0. So both x minus infinity to infinity means it is 1. And f of x is monoatomic where decreasing function. So it is a monoatomic where it is in decreasing function. So you have seen here they have given two variables here, like for s, and they have given y for the y. So I am just putting all the things here. So b means like f of b comma y minus f of a comma y. So they have taken this a and y and b and y. So upper limit minus lower limit will be the answer. Likewise, if it is for c less than y less than d means here c d, right? So I'm just gonna remove the y variable and then you will get the answer. At all points of continuity there will be the derivative, second derivative should be equal to f of xy. So all points in a continuity will be the second derivative, the point. So we have chosen one point, right? So the second derivative of that point should be f of x comma y, means the function should include xy. Okay, and then continuous. So joint probability density function, joint probability density function. So PDF. Okay, here they are saying if d for all or, okay, so d for all or means p of x y for all d will be equal to double integration. So this d is nothing but a region. So this d which is nothing but a region. So they are saying d for all or region. So they are connecting the, means there is a joint between the two regions, right? So this is called joint probability density function. So here we will have double integration. For example, if p of x, y, right? So p of x has some limit and y has some limit, means we have to put those limits accordingly, like x has a to b. So here dx, right? So this is x and this one is d. So up to this we will have a to b limit, then after that c to d limit. And they have some properties like f of x, y will always be greater than equal to 0. We know that should be greater than 0, right? And the whole function should be equal to 1 because this is the last limit, like upper limit. Cumulative density function. So CDF of xy is f of xy. Here cumulative means we need to add up. So for this thing we need to change the limits here. You can see here minus infinity to y, minus infinity to x. So xy are the greatest limit. Here these are the upper limits, but here the lower limit they have extended up to minus infinity. Okay, then if it is a marginal density means f of x will be one single integral, like if it is a x function means we need to put dy, if it is a y function means we need to put dx. That's the difference here, but the limits here are minus infinity to infinity, minus infinity to infinity. So this is the main thing here. Then marginal distribution function, or you can see here first thing is we have to integrate it with respect to dy, and then we need to integrate it with respect to dx. Okay, if it is a x function means first we need to put y, right? So always remember, if it is x means you need to put dy. So I need to first put dy here. First I need to integrate dy and then I can proceed with dx. The same applies here. If it is y means you need to proceed first with dx and then dy. Okay, so here the limits will be either inner limit. Okay, the inner limit will be minus infinity to infinity. The outer limit will be like the cumulative density function limits. Okay, so this is the marginal distribution function, and they have said f of x will be equal to d of f of x, like we need to differentiate this f of x and f of y. one time derivative, and you will get the small x, small function of x. Okay, and if they have given limit means you need to substitute those limits here. And then conditional density, conditional means what? F of function of a by b, right? So this is what conditional. So conditional density of x is given by y. So they are asking for x. So for that purpose, x means f of x by y will be equal to small f of x comma y. So the whole function divided by y. X means x, they are asking for x means we can easily directly write f of xy by f of y. Here f of xy by f of x, they are asking for y. So it is a ulta here. Two continuous random variables are independent. If I say two continuous random variables are independent means I can easily separate it, f of x into f of y. And then they have given one question here. The joint probability density function of random variables. So they have given two variables here is given by a function, and they have given the limits. So they need to find as y should be greater than 1 and x should be greater than half, y is less than 1. So they have given some conditions here. So they want us to find the joint. Joint means double integration. We need to join the two region, right? So for that purpose, if I want to find k value means the double integral of the function will be equal to 1. So as I said here, first we need to find the y and then x. So I am just putting the value for y to 2. Here they have given 0 to 2, 0 to 1. So I am just considering y to 2 and x to 1 here, half of the limit. Okay, sorry, the whole limit 0 to 2, 0 to 1. Okay, so I am just considering the whole limit 0 to 2 and 0 to 1. This is x limit, y limit. Okay, so by doing the integration I will get the value for k. K is what? 3 by 11. Okay, after that I need to find the conditions here. They have given the condition. So y is greater than 1. Y is greater than, we know that x equal to 0 to 1, y equal to 0 to 2, right? But here they have given y should be greater than 1. So I need to take 1 to 2 limits here. So 1 to 2, but here they didn't give x condition. So x is the same 0 to 1 and find the value here. You will get the value, and then here x should be greater than half. So I need to take half to 1. Y is less than 1, right? So I need to take y up to 1 only, not beyond the 1. So 0 to 1, here half to 1. So the limits are set according to this identity. But here you can see here x plus y which is less than equal to 1. So I am just taking the x as same. But in case of y which is equal to 0, if I want y upper limit, y means I need to take like 1 minus x, right? So 1 minus x. So the function, and you will get the answer here. I just work out the last one here, like the third condition. You can see here x y plus y square. So by differentiating with respect to y, integrating with respect to y, right? So xy square by 2 plus y cube by 3. So you can see here this is a thing, and you need to substitute this 1 minus x in terms of y. So you have to apply the formula. You know a minus b the whole square will be equal to a square minus 2ab plus b square, and a minus b the whole cube will be equal to a cube minus b cube minus 3ab into a minus b. So this is the formula here. I am just substitute the all formulas and then just simplify it one by one, and you will get the term at last 3 by 88. Okay, this is the answer. Next comes the functions. Okay, the functions of random variables. What are those functions? Okay, let x be a random variable defined on the sample S. Okay, and they are including g function also. So g is also a function such that y equal to g of x. So I can easily say y variable has some g of x. This is also a random variable defined in S only. Then the probability density function of y will be given by dx by dy into f of x. So probability density function of y will be dx by dy, the determinant, into f of x. They are asking for y, so I am just multiplying it into f of x. So the problem, a continuous random variable has probability density function f of x. They have given one function and f of x is 0 means which is elsewhere. So I need to take the limit here 0 to 2 and this function. They are asking me to find the probability density function of y, 3x plus 2, right? So for this thing I need to first find x here because I need to find dx by dy, right? So I am just replacing this to x form and then I am just differentiating it. I will get the value as 1 by 3 and then f of x is which is nothing but x by 2. So the formula is what? Determinant of dx by dy into f of x. By substituting it, I will get the value here. So f of y will be equal to this function in the limit. Next, transformation. Transformation of 2D random variable. Okay, variables. So transformation means like x to y. This is one plane, right? So I'm just transform it to uv. So this is the main thing here, transformation. uv defined by the transformations, u will be equal to u of xy function and v will be equal to v of xy function. Then join probability density function will be equal to, we need to include the Jacobian form here. So g of uv function which is equal to Jacobian of f of xy function. You can see here it is uv, here it is xy. So transformation. So joint means Jacobian. The only thing added is join to Jacobian form. Jacobian, which is nothing but they have given the x equation and y equation. We need to partial differentiate it with respect to u and v. Again u and v. You can see here x dou x by dou u. So with respect to u, and then dou x by dou y with respect to v. Same applies here. This is called Jacobian form. Okay. So a problem. The problem is the PDF of random variables x, y. They have given one function f of xy. Okay, f of xy is this function. X equal to x is greater than 0, y is greater than 0. So they want us to find the distribution functions of this value. For this thing, I need to transform it first. So what is the function here? X minus y by 4. I am just taking this function as u and v which is equal to nothing but y. So u equal to the given function and then v equal to y. So this is the thing, I am just assuming it here. So then you can easily write. So from this equation, from this u equation, I can easily replace it to x form by substituting the y as v here. Okay. So you can see here y with respect to uv and like x which is has the function uv and y is also has the function uv, right? So after that I need to find the Jacobian form. Dou x by dou u, dou x by dou v. So I need to differentiate it with respect to u, v. Here 4, here 1. And then again this part, there is no u part here. So it will be 0. And v part is 1. You can get the value as 4. So as you know, I have found the value for Jacobian and then I need to substitute this f of x value they have given here. So substitute all the values and x and y functions Substitute the xy functions, you will get the function g of uv as this function. After that, they have given the limits here. X is greater than 0 and y is greater than 0, right? So y is greater than 0 means v is greater than 0. For x, we need to find it. X greater than 0 means we know the x equation like x equal to 4u plus v, right, which is greater than 0. So this is the thing. So 4u plus v is greater than 0 and I need to take v alone. So this so this 4u will go there as minus 4u, right? So you can easily find like, so minus 4u means it should be either equal to 0 or it should be either minus negative, because v is greater than 0, right? So I can easily say which is equal to 0 or it is a minus value. So u which is less than or equal to 0. So this is the thing we have found. So for x is greater than 0 and y is greater than 0, we can easily say v is greater than 0. But in case of u is less than 0 here. So for u less than 0 means we can easily write the function f of u as minus 4u, because this is the lowest limit here, minus 4u to the upper limit is infinity into the function, the whole function g of uv function into dv. So by doing so, we will get the answer as e power 2u, but here v is greater than 0, so we can easily directly substitute 0 to infinity, right? So 0 to infinity, and I will get the answer as e power minus 2u. Okay, so this is the two functions we have got at this limits. So thank you so much for watching this. So this video contains some important topics, and in the next video I will surely complete this probability syllabus actually, and then there is one more syllabus is there, and we will cover this thing in the next upcoming video. So do watch and study with me. We will complete this engineering mathematics in this lockdown. Thank you so much for watching. Keep watching my video. Bye.